Hello everybody. So before we start number 47, something I realized is that on number 45, I forgot to go over how to find the asymptotes. Just in case that's asked, I'd like to make sure to do that as well. So let me extend this page here. And if you wouldn't mind, if you can go back to number 45, we would also like to find the equation of the asymptotes, which would be through the center and then through each corner. And these are the lines that make sure that the graphs never touch. So if I'd like to find the equations of both of those, we are generally going to always use point-slope form. I'm going to write that down first. And then the point that 100% both of these lines go through is the center, and that point is -2, 3. So we would have y minus 3 equals a slope times x plus 2. And to find that slope, the easiest way to do so would just to be counting from the center to a corner. So that's going up 1, 2, 3 over 1. And if we looked at the decreasing line, looks like we're going down 1, 2, 3 over 1. So my slope would be 3, and if we do both lines at the same time, be plus or minus 3. So my equation in point-slope form would be this. You could multiply that through and get that in y equals mx plus b, but we're not asking you to do that, so no worries. Now if we go back to number 47, we want to find the equation of this circle. And the only thing we need, or the only things that we need to find the equation of the circle, is we need the center and we need the radius. So what I'm doing is just writing the basic formula first. From my picture, I know that my center is -3, -5. So I would have x minus -3 squared plus y minus -5 quantity squared equals the radius squared. And the radius from center to side is 1, 2, 3, 4, 5, 6 units. So my radius is really 6 quantity squared. So my final answer would be x plus 3 squared plus y plus 5 quantity squared equals 36. Done. The next shape I want to find the equation of is an ellipse. And this looks like a horizontal ellipse to me because the distance from this point to this point is larger than the distance from this point to this point. And so that means that my major axis is going to be horizontal. So I will make a note that this is a horizontal ellipse. So if it's horizontal, what I'm going to do is, it doesn't matter if x goes first with this, but I'm going to go ahead and just write a general equation. I'm going to put a under here because it's horizontal. Horizontal always leads to the major axis, or if this was vertical, the vertical would lead to the major axis. Whatever type of ellipse it is always ends up describing A. An ellipse always has a plus sign, y minus k squared over the minor axis equals 1. So that's what we want eventually. So the distance from -8, 3 to 4, 3, that is a distance of 12, which means that A is defined as half of the distance of the entire major axis. So A must be 6, which means the bottom must be 36. B is defined as the minor axis, and you're going from -2,7 to -2,1. So the distance from here to here, that distance is 8 units, which means B must be half, so B must be 4, which means that B must be 4 squared, or 16. Now to look for the center. If this whole thing is 12, the center is 1, 2, 3, 4, 5, 6 units from each side. So that is the point -2, -3. So that means that we have x minus -2, or plus 2 quantity squared, y minus -3, which is really plus 3 quantity squared, equals 1. So this would be the equation of my ellipse with the plus sign equaling 1, and that it's a horizontal ellipse, so the larger number must be underneath the x. Number 49, this is a hyperbola. And so to find the equation of a hyperbola, we first need to determine what type of hyperbola it is. Because the pieces are going up and down, or up forever and down forever, this means to me that this is a vertical hyperbola. So that means in a hyperbola, whatever is positive determines what type of hyperbola it is. So that means that the y must come first, and underneath the y would be the a, because the major axis goes with what type of shape you have. Hyperbolas are always minus. Then the minor axis this time is going to be horizontal, and the minor axis is b squared, and it's going to equal 1. So if we think backwards, we can find out what the center is, what A is, and what B is. And so what we have on our graph here is we do not have the center, but we have the two vertices. And so let's think about what the distance is from here to here. The distance from 4, -2 to 4, -10 is 8 units. And the distance from the vertices is going to help determine what A is. And so A would have to be half of that distance. The blue dots here are your foci. And the distance from here to here, from 4, -14 to 4, 2, is 16 units, which means that my C value must be 8. Now, even though we don't need C in the equation, we need C to help me find what B is. And because we have a hyperbola, we have a minus here, my Pythagorean theorem relationship is a squared plus b squared. So we'd have c squared, or 64, equals 4 squared, or 16, plus b squared. If you subtract the 16, we would get b squared equals 48, which means that b is equal to the square root of 48. And there's no reason to reduce this because you're going to plug this right back in and square it. So here would be my answer. Well, actually, almost my answer. Let's see what we got. So now we know that a is 4, so this bottom must be 16a squared. B squared is, well, b is root 48, so root 48 squared is just 48. Let's see if we can find the center. The center is going to be directly between the vertices and directly between the foci. So the point directly between here would be 1, 2, 3, 4. 1, 2, 3, 4. Looks like that is at 4, -6. So if my center is at 4, -6, we would have y, and be careful here, y comes first, so the 6 goes with that. So y plus 6 quantity squared minus x minus 4 quantity squared equals 1. There is the equation of my hyperbola in standard form. Number 50, find the equation of a parabola with a focus of 1, 1, and a directrix at the vertical line x equals -3. So we're trying to find the equation of a parabola, and what I know is that the vertex of my parabola is directly between my focus and my directrix. So this is 1, 2, 3, 4 units long, which means that my vertex must be 2 units away from each of these. So I'm going to make a couple notes. I know that now that my vertex must be at -2, 1. And also, I now know, because what P is defined as, the focal length, which is really P, is the distance from the vertex to the focus and the vertex to the directrix. And that distance is 2 units. So because my directrix is right here, my parabola, again, because it's always between here, my focus is always inside the parabola. So I'm thinking that my parabola must face this direction because the parabola never can pass this vertical line and the focus has to be within there. So if my parabola is facing that direction, that is an unusual looking parabola. We're used to the ones facing up, which is x squared, which means this must be a y squared situation. So that means that my general form is going to look something like this, where the x is not squared but the y is. And we can already fill in part of this because we know that the center is -2, 1, x and y. You would have y minus 1 quantity squared. And actually we can fill in everything because we know that the focal length, or P, is 2. This is really 4 times 2 times x minus -2 because the h value, so the vertex, if I had to be a little bit more careful, rather than labeling that x and y, we should label that h and k, just to be clear. So my final equation will be y minus 1 quantity squared equals 8 times x plus 2. So the key is knowing or remembering that the focal length is from the vertex to the foci and the directrix, or the vertex to the directrix. Also, like in the final equation, that the 8 is positive. If this 8 was negative, the parabola would be facing this way instead, but I knew it had to face this way, which is why I'm glad this 8 is positive. 51. Find the equation of a hyperbola with the vertices at 4, 3, and 4, negative 3. So let me graph that. All right, so as soon as I see the word vertices, vertices are always on your major axis in a hyperbola. So that means that these really have to deal with A. So the distance between this point and this point would be 6 units long. So the distance is 6. And because vertices, again, are always on the major axis, that means that my A value is half of 6, or 3. This problem also gives that I have foci at 4, 5, and 4, negative 5. And foci really go with the letter C. So the distance that I have here from this green point to this green point is 10 units, which means that my C value is half, or 5 units. So before I even write an equation, I know that I can find my B term. Because I have a hyperbola in the equation has a minus, which means that my Pythagorean relationship must be a plus. So I would have 5 squared, 25, equals 3 squared, 9, plus b squared. So b squared would equal 16, square root, so b is 4. Now, we have to ask ourselves, what type of hyperbola is this? Because the vertices and the foci are related vertically, I know that this must be a vertical hyperbola. And if it's a vertical hyperbola, that is again determined by what is positive. And so that means if it's vertical, the y must be positive. So the y minus k squared must go first, and the a squared has to be underneath it because that's the type of shape it is. There always is a minus with a hyperbola. X minus h quantity squared over the minor axis b squared equals 1. So we already know that a is 3, so that means that this bottom must be 9. We know that b is 4, so we know that this denominator must be 16. All we need to do is find the center. And the center, again, is always right between the vertices and between the foci. So this is a distance of 6, so 1, 2, 3, 1, 2, 3. The center is 4, 0, which means that here I have y minus 0 quantity squared, x minus 4 quantity squared equals 1. So the most reduced version would be y squared over 9 minus x minus 4 quantity squared over 16 equals 1. Answer in standard form. And again, I like this because the y squared is positive, and I know from the picture that it's vertically based because all of the points are related vertically. Now for this question, I didn't ask you to graph this hyperbola, but because it's vertical and these are the vertices, if you're interested, your graph would look like this and this, and then you would have a rectangle in between, something like that, just as a general sketch. I would like to go back to the parabola because I realize we haven't graphed a parabola yet. So if you were to actually graph this one, this 8 comes in handy again from the focus. This is the entire focal length, and so you would split that in half and go 1, 2, 3, 4 from the focus, 1, 2, 3, 4 down, and then you would connect these dots with the vertex if you want the exact width of it. And so that would be how you would specifically graph your parabola. All right, guys, so I do not want this last problem to be super rushed, so I'm going to do one last video with just this problem on it. And so I'm going to pause this video now, and please go to the last one to watch number 52. Thank you.